Hi everyone, in today's lesson we're going to learn about how to solve systems of equations using Cramers Rule. We've already learned elimination, substitution, Gauss-Jordan elimination with back substitution, and with matrices in reduced row echelon form. The last and final way to solve systems of equations is using Cramers Rule. So below, from here to here, is the definition of Cramers Rule, and it works best if I show you through an example. So there's basically two steps. You need to find a certain number of determinants and then find the solutions by dividing the determinants together. So the first thing that we want to do is create the coefficient matrix. So if you look here, we have a1 times x, so that would be like 2x, and a sub 2 times x would be like negative 4x. So you take the coefficients of the x's and you put them in the first column, and then you take the coefficients of the y's and you put them at the second column, and we're going to call that the coefficient matrix and label it with D. So let's do that first. So we have D equals 2, negative 4, negative 5, and 3. And what we're going to have to do is calculate these determinants. So we know how to do that. We multiply across, so this is 6 minus 20. So the determinant is negative 14. Then if we want to find dx, or d sub x, we want to find the matrix where you replace the x values with the constants. So if I want to find d sub x, I'm going to replace the x values with the constants, or the coefficients of the x values. So you see how I have a 2 and a negative 4? I'm just going to put the 3 and the 8 instead. So the 3 and the 8 are the constants, so they're going to go there. And then I just leave the y values as is and calculate that determinant. So 9 minus a negative 40 is 49. And then the last determinant that I'll need to calculate is d sub y. And d sub y is the matrix where you replace the y values with the constants. So we're going to leave the x values, and instead of the y values, we'll put 3 and 8. So 3 and 8 go here, and the a values stay. So 2 and negative 4. And then we calculate this determinant, so 16 minus negative 12, and that gives me 28. So these are my three determinants that I needed to find, here, here, and here. So if I want the x value, all I'm going to do is find d of x over d. So the x value, I'm just going to move this a little bit. The x value is the determinant d of x over the determinant d. So the determinant of d of x is 49 over d, which is negative 14. And the answer is negative 3.5. And then if I want to find the y value, so x equals negative 3.5, I'm going to take the d of y and divide it by d. So the y value is d of y over d. So d of y is 28 over negative 14, so the y value is negative 2. And we could always check our system to make sure it works by plugging in our x values and our y values into the original equation. So we could do that. So we've got 2x minus 5y equals 3. So 2 times negative 3.5 minus 5 times negative 2. And I want to see if that equals 3. So take a minute, type that into the calculator, and see what you get. And you should get, when you typed it in, you should get 3. So this works. And you should also check the other equation. So negative 4x plus 3y equals 8. So negative 4 and then negative 3.5 plus 3 times negative 2. And we should get 8. So take a minute, type it in the calculator, and see what you get. And you should get 8 both times, so both answers work. Okay, let's see how this method applies to solving a system that's a 3 by 3. Okay, so the system is going to work the exact same way, where you need to find the coefficient matrix, the matrix where you would replace the x values with the constants, then the matrix where you would replace the y values with the constants, and then the matrix where you would replace the z values as constants. So a 3 by 3 just changes the fact that we're going to have one more matrix. So with these 3 by 3s, the work is a little bit harder to find each of the determinants, so I'm actually okay with you using the calculator. I just need to see the steps. So I need to see the determinant matrix. So for the coefficient matrix, we have -1, 2, and -3, 2, 0, and 1, and 3, -4, and 4. Now, where I got these numbers were from, I just pulled the coefficients here. So -1, 2, -3, 2, 0, because there's no y value, and then 1, 3, -4, and 4. So that's that one. Now, if I want to find d of x, I'm going to replace the x value column with the constants. So we're going to have 1, 0, 2, 2, 0, -4, -3, 1, and 4. And if I want to find d of y, I'm going to replace the y values. So I'm going to keep the x's, replace the y's, and if I want to find d of z, I'm going to replace the z values with the constants. So -1, 2, and 3, 2, 0, and -4. I'm going to try desperately to fit this. -1, or excuse me, +1 with the constant, 1, 0, and 2. So what I'd like you to do now is pause the video and type all of these matrices into the calculator and find their determinant. So I need 4 numbers. I need the determinant of this matrix, the determinant of the x matrix, the y matrix, and the z matrix. So take your time, plug them in, and get me 4 numbers. Okay, this is what I got. Okay, now if I want to find the x value of the solution, I'm going to take d of x over d. The y value, I'll take, whoops, this is a typo, this should be d of y over d. And if I want to find the z value, I'll find d of z over z. So x equals d of x over d. So 10, oops, excuse me, d of x is 8 over 10, which reduces to 4/5. Y is d of y over d, so -15 over 10, which is -3 over 2. And z is d of z over d, so -16 over 10, which actually reduces, if you divide top and bottom by 2, to -8 over 5. So my final answer is 4/5, -3/2, and -8 over 5. So take a minute, plug your answers into each of these 3 systems, and see if it works. Or you could just plug this original matrix into the calculator and hit reduced row echelon form. Okay, have a good night. We'll see you tomorrow.